Monday, the 15th of May, and as promised, it's time for an Oroville update in the mighty Luscombe. This may very well be a historic update, as this may be the last time that we see water spilling over the busted spillway in its present condition using the canyon, Croyle Canyon, so to speak. I want to take this opportunity to personally thank Jeannie Cuddle, the head engineer at DWR, for personally calling me back and answering a bunch of questions I had from our last update. And she affirmed that, once again, you guys that are watching these updates regularly are correct. The latest plan is to rebuild the spillway from the bottom up. So let's get in the air and we'll talk about it up there. Remember, on the audio, when we're in the air, the audio is a voiceover made from the comfort of my Barco Lounger, because listening to this thing in the air is just like listening to a garden tractor.
See, that's what it sounds like at full volume. So let's pull the volume down to a reasonable level. Approaching Oroville Reservoir from the south at 2,500 feet and about 90 miles an hour in the mighty Luscombe. This is Bidwell Dam on a small branch of the reservoir. Oroville Reservoir is open for business and boating this year, but the only marina that's going to be available is Bidwell Marina, located just about underneath the airplane right now. Today I've opened up the window to the Luscombe even a little bit further to get even a clearer view. And all these houses you see between Bidwell Dam and Oroville Dam is a development called Kelly Ridge. And the elevation is located just above Oroville Dam. Looking at the backside of the dam with the current lake level of already down to 838 feet. And on to the left you can see the intake structure to the Hyatt power plant. Remember, this slope structure has gates at varying depths of reservoir elevation to control temperature for the fish downstream. These two inlets feed all 6 turbines of the Hyatt power plant, and the good news is the river valve outlet system is finally up and operational in the bottom of the original diversion tunnels, providing an additional 5,000 CFS flow through the Hyatt power plant. As we approach the main spillway from the backside of the dam, we become aware of another very delicate dance that the DWR is having to play with Mother Nature right now. During the emergency, the DWR was reluctant to reduce the throttle on the main spillway below 50,000 CFS to avoid head cutting of the busted spillway. That in turn required that they turned off the spillway quickly at 835 feet reservoir elevation to avoid scouring of this inlet structure. But since this is the last spill before repairs are to be made to the spillway, they can bring the gates down slowly, reducing the flow gently and lowering the reservoir elevation to the bottom of the spillway carefully to about 813 feet. The inflows to the reservoir lately have varied wildly between 5,000 and 25,000 CFS. We've had a long, cool spring, which has allowed a gradual melting of the snowpack. And the bottom line is the inflows are dropping rapidly to the point where all 5 turbines of the Hyatt power plant plus the river valve outlet systems should easily be able to handle the inflows. What the final elevation of the Oroville Reservoir will be this summer is anybody's guess, but I suspect it'll be quite low. This is the main boat ramp at the dam, which is going to be closed this season and probably next, forcing everybody into Bidwell Marina, located back here on the other side of Kelly Ridge, which is open for business. Now here's what I called the controversial parking lot structure at the end of the emergency spillway. Controversial because we weren't sure if it was set on bedrock or just set on top of dirt, and whether this was part of the reason for the emergency evacuation. Now coming around further, we can see the shotcrete poured in front of the emergency spillway. Here shown in yellow is the length of the emergency spillway plus the length of the parking lot, which water overflowed back in February. The emergency spillway is a large monolithic segmented wall poured on top of bedrock, not doweled into it, just poured on top of. Commonly known as an OG weir. Here's when the water began to pour over the emergency spillway back in February. Why was this allowed to happen? Well, after the spillway busted, nobody was sure what the spillway could handle as far as outflow. It was shut off for a couple of days for inspection and repair and reopened at 50,000 CFS. Record-breaking rainfalls brought a spike of inflows to 197,000 CFS, and the lake quickly rose to 900 feet elevation to this point here. The lake level continued to rise, inundating not only the emergency spillway but the parking lot beyond, and created enormous erosion on the hillside below. And this is just at 12,000 CFS over the emergency spillway. At this point, the evacuation was ordered. The main spillway opened up to 100,000 CFS and the lake level brought back under control, but at a price of much more damage to the main spillway. So it was this rapidly eroding canyon under the red arrow heading back towards the emergency spillway and possibly taking out a segmented section of the spillway that was the cause for the evacuation. So why do we need an emergency spillway? Well, unlike a concrete dam, Oroville is an earth-filled dam, and you cannot, absolutely not allow water to overtop an earth-filled dam. So as part of the recovery effort for the emergency spillway, a deep cutoff wall is going to be cut deep down into bedrock, well downstream of the emergency spillway, and that distance between the cutoff wall and the emergency spillway to be filled with roller compacted concrete, forcing any erosion to occur well below the cutoff wall. So the whole idea of an emergency spillway is often misconstrued. It's to be used as a slow blow fuse only in the event of an emergency to allow a reasonable evacuation time in an effort to save the main dam. And as we come around, we see the final historic spill down the busted spillway as DWR can now slowly close the gates over the next 5 days or so to get a better drain on the lake. So after extensive geologic testing and with the time constraints of only 5 months until next November, engineers have decided that the upper half of the main Oroville spillway is in good enough condition to last another season. Once this final spill is over, crews are going to set about finishing off the demolition of the lower half of the spillway with low-level explosives and excavators, and then take the rocks that have come out of the spillway, get them crushed, and put them back into the hole along with roller compacted concrete and bring the whole bedrock level back up to the spillway grade, and then rebuild a lower spillway out of reinforced concrete that has the capacity to handle 100,000 CFS for next season. The upper half of the spillway will be repaired to where it can handle a rated flow of 270,000 CFS, and the difference, any difference in flow above 100,000 CFS will be allowed to flow back into the existing canyon for just next season. After next season, the lower spillway will continue to be rebuilt to handle a full 270,000 CFS flow, and I believe the upper spillway will also be replaced and or rebuilt. Remember too, these are just design consideration numbers. Operationally, 160,000 CFS is the maximum flow out of Oroville that the levees downstream can handle. Anything more than 160,000 CFS out of Oroville constitutes an emergency. Now we'll swing around here and take a little closer, tighter loop and see if we can see some more of the recovery effort underway. Coming around to take a good look at the inlet to the main spillway. The red lines you see on the dirt below is the old flotation barrier to block the logs and debris from getting into the inlet to the main spillway. The Kiewit contract at this time has nothing in it to provide for rebuilding or replacing the head structure or gate structure to the main spillway. All the transmission lines you see below, both temporary and the old permanent lines, are going to be rerouted from the Hyatt power plant due west away from the entire Oroville Dam and spillway structure. Some of the massive pipes folks thought they saw coming out of the emergency spillway are actually culverts for this access road, or right down here. Crews will continue to decrease the angle of inclination of the steep canyon walls there to improve worker safety below, again using low-level blasting. On the south side of the spillway, 3 large landings have been created, and we'll have to watch over subsequent flyovers to see if this is where they set up the batch plants or the rock crushing. And there it is, the last rainbow we'll probably ever see over the Oroville Spillway, California's newest formed canyon. We come back over the dam and turn and look down the spillway, you can get an idea of just how far away the damaged area is away from the dam itself. So stay tuned for future flyovers and updates of this amazing engineering feat as Oroville officially moves into the recovery phase of the operation at Oroville Dam and Spillway.